Today, we are going to talk about the formulas of the isoscore 1,2,3 iodine.
Does it decay or undergo fission or fusion? What type of nuclear reaction? What are the parent or daughter nuclei? The detailed decay mechanism is electron capture to form an excited state of the nearly stable nuclide tellurium 123. This excited state of tellurium 123 produced is not the metastable nuclear isomer tellurium 123M. Iodine 123 is not an absolutely pure gamma emitter, although it is sometimes clinically assumed to be one.
Okay. The iodine 1,2,3 half-life is 13.22 hours. Iodine 1,2,3 is produced in a cyclotron by protons irradiation of xenon in a capsule. Xenon 124 absorbs protons and immediately lose neutrons and protons to form xenon 123, or else lose two neutrons to form calcium 123, which decays to xenon 123. The xenon 123 formed by other rocks then decays to iodine 123 and is collected on the sides of the capsules under the refrigeration, then elute with hydrate sodium hydroxide in a halogen disproportional reactions similar to collections of the iodine 125 after it is formed from xenon by neutrons irradiation.
Iodine 123 is used in diagnostic imaging and as radiation sources in radiation therapy. It is used in hospital by doctor.
The 1,2,3 iodine gives off gamma rays, which can be seen with special nuclear medical cameras. This allows us to see residual serous tissues, small amounts that are left after serous removal, serology, and any other places where there is still serous cancer.
How is the isotope used to address a specific problem and how effective is the isotope? Zeros while allowing a small diagnostic dose of iodine 123, your intestines will absorb it quickly and it will enter your bloodstream. Then it will go to your thyroid and to any thyroid cancer sites. Iodine 123 is the most suitable isotope of iodine for the diagnostic study of thyroid diseases. The half-life of approximately 13.30 hours is due for the 24-hour iodine uptake test, and iodine 123 has other advantages for diagnostic imaging thyroid tissue and thyroid cancer metastasis.
Death of a large proportion of cancer cells within the endometrium. Death of mesenchymal disease at the periphery of the tumors that would not be visible to to the neck ice, ability to shrink tumors, related safety for the patient, organ preparation, simulations of an immune response against the tumors.
Drawbacks: damage to surrounding tissues, inability to kill tumor cells that cannot be seen on imaging scans and are therefore not always included on the 3D models of radiation planning, inability to kill the all cancer cells in tumor, inability to relieve mass effect, thereby requiring surgery, poor killing of cancer cells in areas that do not have a good supply of oxygen, increased incidence in wound complication and poor healing, inconvenience of radiation therapy, contraindications to radiation therapy.
Radiations and how much to deliver. This means there is usually less damage to nearby healthy cells and reduce the frequency and severity of side effect. So I think these isotopes should be continued